We are going to cover the second session of case control studies, which will deal with analysis and interpretation of case control studies, as well as advantages and disadvantages of case control studies over other designs. Analysis of case control studies. Results of analysis of case control studies will provide an estimate of relative risk in terms of odds ratio, assuming that controls represent the general population in frequency of exposure. Also assuming that cases are representative of all the cases of the disease. And finally, assuming that the frequency of disease in the general population is small in terms of prevalence or incidence. Calculation of odds ratio in matched case control design. The odds ratio is calculated as the ratio of the odds of exposure among the cases to that among the controls. For example, if you see this table of case control study, Unmatched design, you can see that A in the table represents a case which is exposed, B represents a control that is exposed, C represents a case that is not exposed, and D represents a control that is not exposed. The odds ratio, therefore, which is a measure that we are getting from case control studies, can be derived by dividing the odds of exposure, which is A divided by C. You divide the whole of that by the odds of exposure among controls, which is B divided by D. And that can be simplified to get AD divided by BC. And that's the odds ratio. Alternatively, you can also get the odds ratio by the cross product, which is A times D divided by B times C. That's cross product. That is an easier way of getting the odds ratio. For unmatched design, we can give this numeric example instead of using letters to determine the association between coffee drinking and pancreatic cancer in a case control study. You can see that the case series, we have 151 cases and we have 336 controls. And among these, we have 140 cases which are exposed to coffee drinking. And we have 280 controls that are exposed to coffee drinking. We also have 11 cases not exposed to coffee drinking and 56 controls not exposed to coffee drinking. The odds ratio, therefore, can be calculated, as I said before, by the cross product of 140 times 56 divided by 11 times 208, which gives you 2.5. And this odds ratio of 2.5 can be interpreted as saying those who take coffee, those who are exposed to coffee drinking, are 2.5 times more likely to get pancreatic cancer than those who are not exposed to coffee drinking. That is how we would generally interpret 2.5 as the odds ratio. At the same time, we have to calculate also the 95% confidence interval of the odds ratio by that formula, which is confidence interval is equal to the odds ratio times raised to the power of 1 plus or minus 1.96 divided by chi. That formula should give you the lower value of the confidence interval and the upper value of the confidence interval. We shall see that later. For the matched design, calculation of the odds ratio is a little bit different because here we are considering pairs. We are not considering single case and single control. We are considering pairs in which we have one case and one control. Therefore, the odds ratio should be calculated as the number of pairs with an exposed control and exposed case, divided by number of pairs with exposed control and an exposed case. If you take a look at the table below, you can see that we have controls at the top and we have cases on the left. Controls are categorized into the exposed and not exposed, and the cases are also categorized into exposed and not exposed. In this case, A will represent not a single case or not a single control, but a pair in which we have both the case and the control exposed. And D, which represents a pair in which both the control and the case are not exposed. And we call these concordant pairs. The table also shows B, which is a situation where the control is not exposed and the case is exposed. And C, which represents a pair in which the control is exposed and the case is not exposed. These are called discordant pairs. The importance of the discordant pairs is that these are the ones which are going to be used in the calculation of the odds ratio. However, concordant pairs, which are A and D, these will not be used in the calculation of the odds ratio because they don't give any information regarding etiology of the disease in the cases. So we shall be using the discordant pairs, which is B and C. And the odds ratio, therefore, is simply B divided by C. It becomes very simple, especially when we are using pairs and when we are using the simplest category of case control studies, which is having one case and one control. When we go to using several controls per case, then the situation becomes a little bit more complex, but there are means and ways of calculating the odds ratio in those kinds of situations. If we give a numeric example of the matched design, here we are considering the association between oral contraceptive use and thromboembolism. In a matched case control study, for example, we have controls who used oral contraception and controls who did not use oral contraception. We have cases who used oral contraception and we have cases who did not use oral contraception. Here we have 10 pairs in which 10 controls used oral contraception and 10 cases used oral contraception. And we have 95 pairs in which 95 controls did not use contraception and 95 cases did not use contraception. These are the concordant pairs, and therefore they will not be used in the calculation of the odds ratio. When we consider discordant pairs, these are 57 and 13. These are the situations where we have variance. Controls did not use contraception, while cases used contraception. And so, in order to get the odds ratio, we will divide 57 divided by 13, and we get 4.4, which can be interpreted as saying those who were exposed to oral contraception are 4.4 times more likely to get thromboembolism than those who were not exposed to oral contraception.